Here goes a lesson on graphing sine waves. So we're going to start off with some definitions and then we're going to start graphing our sine waves, okay? So the first thing we're going to do is start with cycle of a periodic function. A cycle is a portion of a graph from one point to the point of a graph where it starts to repeat itself. So the sine and cosine waves, as you know, are going to start repeating themselves. A period is the change in x corresponding to one cycle, how long it takes to complete one cycle. An amplitude is the distance from the node line to the high or low point of the graph. A phase shift is a horizontal displacement. That's how far to the left and right it's going to start. And then frequency is the number of cycles in 2 pi. So if you need to pause the video to copy the rest of those definitions down, feel free to do so, because we're moving on. What we're going to do here is we're going to stretch the unit circle out on an XY graph. So you know a unit circle goes around and around and around, but XY goes forever up, down, left, and right. So what we're going to do is we're going to start by taking the unit circle and we're going to stretch it out to a normal sine curve. So the first point we have is at 0 radians, and remember, sine is equal to the y value of these coordinates. So at 0 radians, our y value is 0. Now, as you go, look at what happens to y. The y value is increasing as you go up, but that's as you're going to pi over 2 radians. So as we approach pi over 2 radians, this graph is going to increase. Okay, but then you're going to get to pi over 2. So at pi over 2, you reach the maximum height of this graph. And then the y value, as you approach pi, is going to start to decrease. So the y value is decreasing as you get to pi. Now look at what happens when you get to pi. Your y value is back at 0. So once you get to pi, you're back at 0. So, but look at what's going to happen now. As you go to 3 pi, the y value is going to decrease again until you get to the very bottom, which at the very bottom of 3 pi over 2, you are back at a distance of -1 from the origin, which is why you're -1 below the x-axis. And then from there, as you can see, the y value is going to increase. It's still negative, but it's increasing as you go back to a y value of 0. And once you get to 0, again, as you'll see, the graph is going to start repeating itself again. And that cycle will continue forever and ever and ever. If you were to stretch it out, it's just going to look like this, and it's just never going to stop. Okay, so that's what a sine wave looks like. Now, sine waves will always start here at the origin, 0, 0, until we start shifting left and right, up and down. The high point of a sine or a cosine wave is called a crest. Okay, that's the high point of a sine or cosine wave. The low point is called a trough. Okay, so this is a trough. And then your axis, or what we're going to call is the node line, that is our starting line, basically. That's the average of the high and the low. Now, the period for a normal sine wave is going to be 2 pi. And of course, if you're in degrees, we would call it 360. The amplitude is how high it goes or how low it goes in respect to the node line. So the amplitude is 1 for this because it goes up 1 above the node line and down 1 below the node line. So those are all the basics to a normal sine wave. Now what we're going to do after that is we're going to start messing with it. So this is the generic form where A is your amplitude. So the number that comes before your sine is going to be your amplitude, how far away from the node line this graph is going to go up and down. B is your frequency. It's how many times this is going to repeat itself in 2 pi, how many cycles in 2 pi. Your C is your phase shift to the right or to the left. Now that is going to be opposite of what you think. And then last you have D, which is your node line. That is your vertical shift. So if it was +5 on the end, your graph would actually start 5 above the axis. Okay, and if it was -5, it would start 5 below. It's your vertical displacement where your node line starts. Okay, so to get a better idea of how this all works, let's just graph one. So to make this graph as easy as we possibly can, it requires a little bit of work in the beginning. So there's a couple of things you want to do. Now what I have here marked in green, that's going to help you graph. And what I have marked in purple, that's going to give you some of your start and your stops and how we scale the graph. So first thing you got to remember is your amplitude. Your amplitude is the number in front of sine. So the amplitude is 3. That means this graph is going to go up and down 3 in regards to the node line. Now your node is how far above or below your axis that you're going to start. So this node actually starts up 1, which means the equation of the node line is y equals 1. Your crest is your high point, which is 3 above 1, so your crest is y equals 4. And your trough is 3 below the node line, so that is y equals a -2. The last thing is your phase shift. Your phase shift is this to the right or to the left, opposite of what you think. So your phase shift is pi/2 to the right. So what we're going to do now is we're going to start setting up the graph, but we're not going to finish it yet. And what you're going to need to do here is you're going to need to make something like that. And what you're going to do is you're going to do 1, 2, 3, 4, 5 tick marks to the right. And you're going to have to do 2 tick marks down and 4 tick marks up. Now, I knew that because I knew my crest was 4, my trough is a -2. I know I'm starting to the right of this graph, so everything's going to happen to the right. And sometimes if you're shifting to the left, you might need some tick marks to the left. And now what we're going to do is a couple of things. We're going to put a horizontal line at our node. That's y equals 1. That's our node. And then we're also going to put a horizontal line at y equals 4. That's our crest. And then we're going to do another horizontal line at y equals a -2, which is our trough. So we have our crest, our node, and our trough. So we know how high this is going to go. We know how low this is going to go. We also know that we're going to be starting with a phase shift of pi/2 to the right, but we're not going to do anything with that just yet. So I'm going to show you what we're going to do now. This is where the purple stuff comes into play. The cycle is this many times in 2 pi. So this is going to happen 4 times every 2 pi. The period is always going to be 2 pi divided by b for a sine wave. So since we have 2 pi divided by b, we know in this case b is 4. So we have 2 pi divided by 4, which is pi/2. That's our period. Our interval is always the period divided by 4. So pi/2 divided by 4 is going to give us an interval of pi/8. Now that's going to help us scale our graph. Okay, so one last thing we need to do. We need to take the 4 times x minus pi/2, and we're going to flank that with less than or equal to. A typical sine starts at 0 and ends at 2 pi before it starts to repeat itself. Now this is the trick for helping you get your left and rights and starting and stopping and all that. So what you do is you solve for x in the middle. So the first thing you do is you divide everything by 4. So 0 divided by 4 is still 0, which is less than or equal to your x minus pi over 2, which is less than or equal to 2 pi divided by 4 is pi over 2. To get x by itself now, we had to add pi over 2 to both the left and right. 0 plus pi over 2 is pi over 2, which is less than or equal to x, which is less than or equal to 1/2 pi plus 1/2 pi is just 1 pi. So the reason why we did that is this is our start and this is our stop. So we're starting at pi over 2 and we're ending at pi. So what are we going to do with those units in the middle? Well, remember that interval we found? That's what we're going to go up by. So 1/2 plus 1/8 is 5 pi over 8, plus another one is 6 pi over 8, which we just reduced to 3 pi over 4, plus another one is going to give us 7 pi over 8, and as you see, we're going to end at 8 pi over 8, which we know is just pi. So that's our start and our stop. Now the last thing you have to do is remember that sine is always going to start right here at the origin. But since we're moving up 1 and pi over 2 to the right, you can see that's where we're starting. See, look, we went pi over 2 to the right and going up 1. And that's why this is your start. You still start at the origin. And sine starts by going up till you get to the top at your crest. And then you're going to come back down and hit your node. Then you're going to go down and hit your trough. And then you're going to come back and hit the node. So you're never allowed to go from the crest all the way to the trough without stopping at the node line first. And then all I need you to do is this. We're not looking for perfection here. If we were to graph that on a graphing calculator and scale it to pi, it would not look like that. It would go forever and ever, but we only need you to sketch one complete cycle of the function. It's more important to know where you're starting, where you're ending, what your high, what your low, what your node is, than to actually try to sketch this accurately. Okay? So that's my example. Now you get to try an example. Again, if I were you, I would start by listing your amplitude, list your node, list your crest and your trough, and then list your phase shift. And then, more side work, make sure you list your cycle, list your period, and list your interval. Now, after you list all of that information on your own, I would like you to press play again and we'll see if you got it all correct before you go and graph it. Okay, and you also, while you're at it, you might want to find your start and stop as well. So pause the video and find all of the important information first. Go get it. So let's see if you have all your important information correct. Your amplitude is 4. I know what you're thinking. It's a -4. The only thing that negative is going to do is it's going to make sure it starts by going down first instead of going up. Typically, sine will start at the origin and start by going up. When it's negative, it starts by going down. Your node line is y equals a -2. Your crest is 4 above, your trough is 4 below, that's why you have a 2 and a -6, and your phase shift is 3 units to the right. Our cycle is pi over 5 in 2 pi, remember it's the b in 2 pi. Your period is 2 pi divided by pi over 5, which if you multiply by the reciprocal, you'll get 10 pi over pi, which is just 10. And your interval is 10 divided by 4, which is 2.5. So from here, we did our start and stop. 0 is less than or equal to pi over 5 times theta minus 3, which is less than or equal to 2 pi. We solve. We're going to start at 3 and end at 13 with an interval of 2.5. So remember, this is going to be lower than it is high. So we're going to start like this. Now, of course, if you don't know how to predict that, you can just do the same size every time. We're going to do a high of 2 and a low of -6. And we're going to have our 1, 2, 3, 4, 5 tick marks to the right. Your amplitude is 4 because your node is a -2. That will get you your node line. 4 above is your crest. 4 below is your trough. Notice how it works out nice. We had our 2 above and our 6 below. Because our node starts at -2, we are going to start right over here, and we are going to end right over there. What are the units or our measurements for these tick marks? It starts at 3, it ends at 13, and it goes up by 2.5. So we have a 5.5, an 8, a 10.5, and then again a 13. And from here, you just graph. So we are going to again start right here. Sine always starts at the node line, but this is where the negative comes into play. Negative just means it's going to start by going down first. So you go and you hit your trough, back to the node, up to your crest, back to the node, and here you go. That's how you graph a sine wave. So hopefully you got that. We have one more question, and all I need you to do is look at the equation we have here and list all of this information. See if you can do this part on your own, and then we'll see how you do. And we have more examples that we'll be doing in class tomorrow on the graphing part. So if you missed anything, go back and watch it again. If not, we're going to do a couple more in class. All right, answer this part on your own. Give it a try. So let's see. You should have an amplitude of 2, not -2. The amplitude is 2. The negative just tells you if you're going to start by going up or down. This one would start by going down. The frequency is 3 in 360. Notice this is in degrees, so instead of you doing 2 pi, you would say 360. The phase shift is 30 degrees to the left because it's opposite of what you think, so plus means left. Your vertical displacement is 7 up. The period is 360 divided by b, which is 120, or if you're doing this, your start and stop, this part is always your period before you add or subtract whatever this is. Okay, so after you divide by this number from 0 to whatever is your period. Your node line is y equals 7. Your maximum y value is 9 because that's your crest, and your minimum is 5 because that is your trough. All right? This is Longo, and I'm out. See you, bye.